Hello, everyone, and welcome back to Indian Genes. Our guest today is a professor of psychology and neuroscience at Princeton University. He probably has written one of the most impactful and interesting papers, I would think, scientific papers of the last decade. And you would probably know him or you would know his theory, which is called the attention schema theory. His research mainly revolves around the brain basis for consciousness and a very interesting subject. But I'm going to try to speak less because I don't think you need a long introduction from me. We'll let him tell us more about what he's doing. So, to all our listeners, here's a very special conversation. Everybody, we now introduce to you Professor Michael Graziano. So, Professor, and if I can call you Michael, thank you so much for speaking to us here at Indian Genes. And I know you've got to spare some time to come here and talk to us, but thank you. And everybody in India welcomes you.
Thank you. It's a pleasure to talk to you.
So, Michael, I think a lot of us listening to this particular podcast would be interested because I've kept your introduction short. I think it's better when it comes from the person himself. So, why don't you tell us a little bit more about what got you started on this road? Why was consciousness something about what you would want to spend time on? And then, of course, as your career progressed, you've spent more time on it. You are doing research, but I'm going to leave the introduction to you, and maybe you can start wherever you want to and tell us how did this all begin.
Sure. Well, first, I think the topic of consciousness is intrinsically interesting, probably to everyone, because we're all users, we all have it. And so everyone's fascinated by that topic. I think a lot of people who get into neuroscience or psychology begin with that kind of interest in consciousness. So I think I was pretty much like a lot of people. That was a topic of great interest to me. When I started neuroscience as an undergrad, I worked on really different topics, far from consciousness. I worked on really nuts and bolts questions. And through my graduate career, my postdoc career, and into my faculty career, I worked on things like how the brain controls movement, how the brain processes sensory input, especially vision and touch. So, kind of low level nuts and bolts processes. It wasn't really until later, until about the past 15 years, that I got into this question of consciousness, that I really began to do research on it. And I think that was kind of just a natural evolution of ideas. It grew out of the work I had been doing before. Um, and so I began to study it, and it's a field that is, in my view, sorely in need of um, focused experiments and a clearer conceptual framework. And so it's been interesting and exciting to work in that area over the past years.
Right. And I think, interestingly, when we talk about consciousness today, the number of definitions that come out to start with is a bit of a problem for somebody who is a non expert or somebody who's trying to figure it out for the first time. Not literally, everybody is conscious, but is trying to get deeper into it. How would you, or what would you say is probably a universal, if you could use that word, definition for consciousness that makes it easier for people to start as a starting point?
Right. Yeah, you're right. Clearly, there's many different definitions. There's many different ways that people think about it. In the science world, or the world of consciousness scholarship, at this point, the main idea, the main definition is consciousness is experience, right? So it's the subjective, what it feels like component. And so it doesn't matter whether you're talking about consciousness of the color green or consciousness of a poke on your skin, um, conscious experience of an emotion like joy or anger. You could be talking about your memory, remembering past events, your sense of self. It doesn't matter what the content is. The content is something else. The content is this computable information. The idea is that consciousness is the experience, the subjective experience, the what it feels like component that goes along with it, that we all, introspectively say that we have. That's the main definition, the main thing people are trying to ask. How do we get a subjective experience of anything at all, whether little or big, whether concrete or abstract? How do we have a subjective experience? That's how it's framed typically these days in the field of consciousness studies.
Right. And I also think that probably when it comes down to the earlier stages, when you talk about consciousness, or when we would have read about consciousness, everybody would go back to probably the Greek philosophers. And Socrates was probably the first person who introduced the concept of something like universals and then the subjects that were down here. And then Plato took it forward with forms, probably for the next few hundred years. That was the theory. And today it has evolved as well. How and when would you say that this particular definition of consciousness changed more towards this subjective feeling, or we are receiving this consciousness and then emitting out? So when did this transition happen, or was it always one part of academics that thought that this should have been the case from the very beginning? Or was it Descartes that formally said, okay, you know what, there's mind and now there's brain? But in your field, probably you would be better to explain that to us.
So I think you're asking two questions. One is, when did the brain get attached to it in particular? And the other is, when did the modern conception that you can separate out the stuff you're conscious of and being conscious of it, right? So let's start with the brain. The idea that the brain is important for thought or, internal events dates back, as far as anyone knows, a very long time ago. I believe the earliest known written mention of the brain and its function is in an ancient Egyptian papyrus. Um, from a very long time ago. And then, of course, Hippocrates expands on that, and people expand on that over the centuries and so on. And so, very early, I think scientists and scholars understood that the brain was important and the brain was the center of thought. I mean, there was other traditions like the Aristotelian tradition where the heart was the center, but the brain won out because all the data piles up on that. So that's one thing. Where did the brain come into it all? Well, very, very early on. But something else happened. You have to understand the real beginning of thinking about consciousness as a thing, not just asking about the kinds of processes like, well, memory is a thing and decision making is a thing and perception is a thing. No, but thinking of consciousness as its own subject to be studied really begins not very long ago, where you don't have to go all the way back to the ancient Greeks or before. It really begins about 100 years ago with William James, the psychologist. And he's the one who actually defines this term stream of consciousness. And so he's the one who says, well, there's something in us that's kind of a stream of thoughts and a stream of perceptions and memories and so on. And to him, that's what consciousness is. And actually, to colloquially, to many people, that's also what it is. But something happens that's really interesting. In the middle of the 20th century, computers come along. And the thing about computers is that computers started to be able to do the things that were supposed to be in the stream of consciousness, right? Computers can remember, they have a memory, they can make decisions, they can choose whether to do A or B. Computers can take in sensory input and process it. They can begin to do these things. And so philosophers began to look at computer technology. Remember, you have Turing, Alan Turing, in 1950, starting to ask whether machines, computers, can ever think like people, right? So now philosophers begin to look at machines and they begin to ask, this is very uncomfortable. We don't want machines to be conscious. We don't want them to be too human like. We don't like that. So I think there was a push, there was an impetus to find something about the human mind that's special. And that's when, after 1950, you're really talking about 1970 with people like Nagel, or 1990s with people like Chalmers, where you get the development of this new idea that there's something extra and special. Machines don't have it, people do. Machines can have memory and perception and decision making, but they lack the magic essence of experience that people have. That's the philosophical concept. um, I personally don't believe that. I think that's a philosophical mistake, but that has tended to shape the field. That's how the field is shaped right now. Consciousness studies is focused on figuring out the extra magic essence that's above and beyond just processing of information in the brain. It's the experience part. And that's very new. Like, that doesn't go back to Descartes or the Greek philosophers. This is very new. This is a concept that really emerged after 1950 in direct response to the development of computer technology.
Right. And you brought in Nagel, and so his what is it to be a bat? I think that could be an interesting point to for probably you would be the best person to explain it to us, and what was he trying to actually get across, because there are so many versions of it. But we can use that as a starting point.
Sure. So, yes, Nagel wrote a now famous paper, What is it like to be a bat? And the essence of his argument, the essence of the idea, again, is that um, there is a what it feels like component to being a human or being a conscious entity, a what it feels like component. You're not just processing information, you have a subjective experience of it. And so he was speculating, well, maybe a bat also has a subjective experience. The bat is conscious of different things than we are. Like, the bat has its own world and its own um, sensory inputs. The bat does its own thing, but it still has a subjective experience of it. There is something it feels like for the bat to do that. That was Nagel's point. So Nagel in the 1970s is already talking about something, an intangible essence that is untouchable and unmeasurable. Um, and I also mentioned Chalmers in the 1990s. Chalmers emphasizes that again. He calls it the hard problem, which is a euphemism for the impossible problem. It's how do we get that intangible, untouchable magic essence inside of us? Well, because it's intangible, because it's untouchable and unmeasurable, therefore science can never study it. So this is the beginning of a kind of view in consciousness studies that has encompassed the field. I call it magicalism. It's actually very unhelpful, but that's kind of the dominating concept of consciousness research, and it kind of begins, in some sense, with Nagel, with what is it like to be a bat.
Right. And I don't know if you're aware of this, but I was looking at an interview recently by Eric Weinstein, and he mentioned that the paper that you had written or co-written, where you spoke about the attention schema theory, which we would want to talk about here, was probably one of the most important papers in the last 2 decades. So I don't know whether you are aware of that, or have I got that right?
Well, I mean, that's good news. I'm happy to hear that. So the attention schema theory I proposed um, in 2011, I think, was the first paper on the attention schema theory, 2011. And I've written many, many, many papers since then on it, but really that first paper lays out the basic story. And so, yeah, so the attention schema theory is an explanation of this phenomenon that people call consciousness. And it's an explanation that avoids the magic. It's an explanation that completely avoids things like the hard problem or the extra essence that emerges from the brain. It tries to get at the question from a totally different angle, and it's of all the theories out there. There are many, many theories of how the brain produces consciousness. There's maybe five main theories, but there's hundreds and hundreds of other theories out there in the literature. And this is the only one I know of, the attention schema theory, that is really entirely trying to get at a scientific, measurable, explanatory level without the magic and without the explanatory gap, as it's sometimes called.
Right. And if we do get into it now, because when looking at it, probably, or reading your paper, which I have done and got into a little bit of detail as well, for somebody who's listening to you for the first time, who is not aware of this theory, I guess for the common person, the first question would be, people are going to talk to you, and I'm sure you've heard this, which is, what about my emotion? What about my feelings? What about my memories? Do uh, I carry this with me? Is there a place in the brain that emits this? Is there a way that this can be controlled? But before we even get to that part of it, starting with the attention schema theory, if you could just give us an overview of what your research is currently doing, and how you're looking at that.
So I think the most important lesson in the attention schema theory, the most important lesson is actually a foundation of the theory. So before you even get to the theory itself, there's some foundational concepts. Um, and here's a very simple set of concepts that I think everyone has to deal with if you try to understand consciousness or your inner self. Everything you know about yourself, everything, when you introspect and you try to think, what am I feeling, what am I thinking, what am I experiencing, what is my world's like, everything you know about yourself derives from information in your brain. This is something we know from neuroscience. The brain has to encode it in a form of information. Otherwise, you can't formulate the thought and you can't say it out loud, because the speech mechanism, uh, operates on information, streams of information flowing through neurons. The higher cognitive networks that construct your thoughts, those operate on the basis of patterns of information encoded by neurons. So everything you know about yourself derives from information in your brain. That's the first lesson. And the second lesson is the information in the brain is never accurate. It's never accurate. It's a little disturbing to think of it that way, but the brain builds what are called models, or bundles of information, chunks of information that describe things, that help keep track of things. And those models are never accurate. They're not supposed to be. It would be a waste of energy to try to build a perfectly accurate model of everything. Instead, the brain builds um, simplified models of the world around you, simplified models of yourself. It means everything you think you know about yourself, or about the outside world for that matter, depends on these highly simplified, partially distorted models, right? They're not really accurate. And so when people assert, I have conscious experience, I have that subjective sense, um, that assertion is based on information, a self description, a self model, and that self model is distorted. It's not perfectly accurate, right? And so um, one can't just take it on face value. It's a distorted description of something else, of something going on in here. And the attention schema theory basically asks, well, what is it? What is the actual measurable, real physical thing in the brain that gets depicted in this kind of distorted, simplified way that causes us then to assert or claim that we have this magical subjective experience. So that's the kind of overarching framework of this theory.
If we do consider going back into our evolution, then how far back did this actually start? Because when we look at probably early primates, consciousness did levels of consciousness as we evolved. And if we go even further back, or currently we look at some animals, a dog is a good example who probably today is domesticated and displays or shows the emotion. So are we saying there are certain animals that do something that's very close to what we're doing, and that we have evolved further because obviously there is a benefit to it?
Right. The evolution of these self models, the evolution of consciousness, this is very, very interesting. Um, so, my guess, we don't know, right? All I can do is go on this theory, which we're building by studying humans. But if the theory is correct, then a lot of these things apply to other animals as well. And probably the basic self models that give us what we call consciousness, conscious experience, those are probably present in most, if not all, mammals, probably most, if not all, birds, right? We're talking about a huge range of the animal kingdom has something of what we call conscious experience. They might not be conscious of the same things, right? As humans, we have a really complex, sophisticated set of uh, ideas and beliefs and knowledge about ourselves. Um, a dog doesn't, a mouse doesn't, a chicken doesn't, but they're conscious of something. They probably have the same kind of mechanism, but apply to a different set of or a simpler set of content to be, yeah, a simpler set of content. You mentioned emotion, and I want to just briefly touch on that. So, um, the circuitry that is involved in the brain that's involved in emotion and building emotion is very old and it's present in all mammals at least, and probably birds as well, uh, and probably reptiles. So there are really basic mechanisms deep in the brain. In humans, there's a structure that's kind of at the base of the brain, the hypothalamus, that's really involved in the range of emotions we have. Dogs have it too. Cats have it too. Horses, you know, pigeons, all these kinds of creatures have the same circuitry. Um, Having emotional circuitry is not the same thing as being conscious, right? Because there's this separate question of whether you have the, this subjective experience of the emotions. That's very different. So there's an interesting phenomenon that psychologists all know about. Of it is possible, it's actually quite common for people to have emotional reactions but not know it and not be conscious of it. And sometimes you have to remind people and say, you're kind of angry today. And then the person might say, oh my God, you're right. I just realized that. So it is possible to have emotions and not have those emotions enter consciousness. Consciousness is a really separate question from the question of emotionality. But both of those mechanisms, the emotional mechanism and the consciousness mechanism, are probably really old and really widespread.
Right. And you did mention language earlier. And if we go back to probably, I'm assuming 50, 60,000 years ago, we did evolve our language and then began symbolic representation or art in some form or the other. Now, I mean, this is just my thought, but if you look at probably, we hear a lot about dolphins, probably they have some way of communicating. There's some language there as well. And I do know that Daniel Dennett was somebody who spoke, especially when it comes to consciousness and the connection with language. Now, because of the way our language evolved, whenever it did or was that one of the reasons or an important reason why, as a species, our consciousness probably moved to the next level? And you could then bracket it into something called meta consciousness or Is this probably not the right way to look at it?
So, evolution of language, really interesting topic. There's a lot of different theories, and it's shifting and changing all the time. There was a kind of view at some point that our language must have evolved around the time that art begins to appear, which would be 60 or 70,000 years ago. Um, but I think that is not a consensus view now. The the idea that I favor is that human vocal language, really rich, um, communicative language, probably evolved with really sophisticated stone tool technology, where you have to tell someone else how to do it, otherwise you can't transmit the skill very well. And that's looking like Homo erectus. Um, uh, 1 to 2 million years ago, some kind of evolution of human speech communication. If you look at other apes like chimpanzees, it turns out have a kind of a language, a gestural language. They use gestures. They don't use a lot of vocal sounds naturally, but they have a really rich vocabulary of different gestures that they learn in the wild, that they use in the wild. And so communication methods are widespread. Human language, this what's sometimes called generative language, the ability to take individually meaningless components and string them together in different grammar, different order, in order to create complex meaning. This is something that may have evolved very early in our evolution, um, but I would say that I know. So you asked about Daniel Dennett and his linking of language and culture to consciousness. Um, Tennant and I were very close in our theories. And I was a great fan of his work. And I hope he was a great fan of my work as well. We often spoke. Um, but there is a difference. And the difference is to Daniel Dennett, consciousness is essentially something learned. It's cultural and it's learned. And if you don't learn it, you don't have it. And to me, in the theories that I work with, to the attention schema theory, that's not correct. Consciousness is not learned, it's built in from birth, and it's present whether or not you have a language. And it's present, as I said, across a huge range of animals. And so people can talk about their consciousness. That's something unique about us. It's the reason why I study people, because it's really hard to study consciousness in animals who can't talk about it. So it's really much easier in people because people can articulate, it comes out their verbal output. And so it's much easier to study consciousness in people. But I don't think it's really fundamentally different in people. Some of the cognition is different. People are very cognitively sophisticated. You pointed to metacognition, the ability to think about your own thinking. This is really sophisticated. This is something we do, um, that other animals probably don't so much. But again, there is a distinction between that kind of operation, the cognitive sophistication, the thinking, the emotions, the perceptions, all of these things are the content of consciousness. Those are separate from the mechanism of consciousness. So I think the mechanism itself is probably really similar in people and other animals. We just have more complicated stuff that we are conscious of.
Right. And you did speak about we all being born with consciousness, but earlier you were also mentioning that knowledge is present in our mind or in our brains at some time, but over a period of time we need to extract that. But are you saying that this knowledge is available and that means all future knowledge is available as well? Is that what you're saying? Or when you said that the mind can deceive you, is that knowledge being created or generated as we go?
Yes, generate as we go. So here's a very simple example. Um, when you look at the world, you see colors. And let's take the particular color of white. You look at a sheet of paper and it's white. Um, your brain, your visual system evolved to represent, to build chunks of information, to essentially keep track of or depict the visual world. And those chunks of information are simplified and inaccurate. They're not accurate. And in particular, we evolved to build a model of white that says it has lots of brightness and no color. Like that's how we see white, lots of brightness, no color. The reason we see it that way is because the model built in our visual system is simplified. It's inaccurate, and it took Newton and many scientists since then to figure out actually white is not that. White is something else. White is a combination of all possible colors to an even degree. Um, but that's not how we see it. We see a distortion, and we see a distortion because our visual systems evolved to produce uh, uh, an easy to compute, simple, good enough descriptor of the world around us. So that's an example of how the brain constructs information, and what we cognitively know about the world depends on those kinds of internal models constructed by the brain. And those models are never accurate, they're always simplified and distorted. So the brain is always continuously generating these descriptive models of yourself and of the world. And those models are what we know.
Does that mean that at any given time, you or me or anybody listening to this conversation, one is has their own view of reality, of course, that is obvious, but at the same time, nobody really has an accurate view of reality because there is some percentage or there is something that's lacking. And for example, let's go back to before we evolved language and this form of consciousness 40, 50. The way humans saw the world at that time would have again been different, would have been real for them. It's different for us now. And does that mean that as we move forward in our evolution, we are going to see things differently when it comes to either, let's stick with color, and there is a probability of another spectrum of that color coming in, or we losing one. So what I'm trying to get at is there is no fixed real reality out there right now.
Well, I'm a realist. I'm a I believe in an objective reality that is out there. I think it's just different from the reality as the brain depicts it. And color is a good example. Most people have three cone classes, or three primary colors that we see: red, green, and blue. And that shapes our color vision. Um, but you're right, that can change. And actually, there is a small sliver of people who have a genetic anomaly. They have four primary colors: uh, red, green, blue, and other blue. And they see color in a different way from the rest of us. They see a color world that is more expansive and has more dimensions to it and is richer. And that's what it is. Their perception is actually different from ours because their brains have genetically have a different kind of model that it constructs, a different bundle of information that it builds to depict the world out there. So yes, um, the perception of the world can change. The reality as we understand it can change. Um, but I think that there is an actual reality out there that anchors it all. So yeah, I don't think there's a view in philosophy called solipsism, where there's nothing out there and it's all a construct of the mind. And I don't think that that's true. I think there is a real reality out there, um, and the brain does its best to come up with an easy, quick, and dirty way of representing it so that we can get along in our daily lives.
And yes, solipsism is probably one of the reasons we have what we have today when it comes to morals or when it comes to ethics, because what they actually preached was if there is no reality out there and it doesn't make sense, then probably pragmatism is one way of or the right way to go about it. And if you have to get to where you have to get you anyway, uh, it's your choice. You get to do what you have to do. But I just wanted to speak to you about when you mentioned color. Then, in that case, there's this famous story, not a story, but the theory about Mary and the colorblind scientist. Now, would you use this story for what you're proposing, or does it in some way contradict to what you're saying?
The way the story works is you invent a situation that can never actually happen in real life, and then you try to make scientific inferences on the basis of a condition that never happens and never will happen. And of course, that's not how science works. Like, actually make Mary, like produce an actual physical Mary, the color scientist, and then we can study her and talk about it. But the idea of Mary, the color scientist, is supposing you took someone who was blind, but you gave her all the information you possibly could about color, about um, vision, about wavelength, and then is that the same thing as her experiencing red? And the answer is no, of course it's not. But what's missing in the color, the Mary, the color scientist, what's missing there, what's missing is the realization that when you or I, when a person says, I experience red, that does not rest, that assertion, that introspective belief, I experience red, that does not rest on solely on visual information. It's not just visual information, it's not just wavelengths and the locations of things and texture. It's not visual information, it's partly visual, but it's also very rich information about yourself. It's information about what it even means to experience something. It's information about how your brain is focusing attention on the red object. It's information about, uh, it's in order to say, I experience red, you need information about who I is, what experience is, and what red is. And so, what the Mary, the color scientist, story says basically is, well, what if we throw away most of that information? Just give Mary the information about visual red, but leave out all the necessary linked information about her self and about what experience is. Just focus on one piece of the larger puzzle. Give her only that. Now, that's different from the case of a person who has all the components, right? And so there's something kind of uh, trivial and philosophically uninteresting about the problem once you really understand what the different components are. So I'm not a huge fan of Mary the color scientist.
As you said, there's another, probably another important component that's not considered, which, as far as consciousness is concerned, is memory. And there are so many components you can add to it. We've not even spoken about that. And you rightly mentioned there are just three components that are considered in that particular situation. But you did mention in passing about attention, and I think we could move on, and this would be the perfect time for you to tell us about when it comes specifically to consciousness and the attention schema theory. When you talk about attention or how important attention is and why, before we get there, could we get an understanding now? I do know that we also have something that's called the body schema, because probably the body schema talks about the human body in relation to its component parts. And is the attention schema related in the same way as a framework?
Right. So the body schema is our brain's simulation or model of the body. So if you close your eyes, you know that you're sitting in a chair, you know where your arms are, you know how they're moving, you have a good sense of the shape of your body, and what it's doing. And that's because you have a representation of it or a model of it that your brain constructs. That's the body schema. One of the best ways to demonstrate the body schema is unfortunately, a medical accident. Let's say you have an arm amputated. Lots of people with amputations. The arm is gone, but you still have a phantom limb. Most people with amputations have a phantom, a feeling, ghostly feeling that the arm is still there. They can even feel the fingers. Um, and when they imagine moving it, it feels like a real arm moving. So, what is that? What is a phantom limb? It's the model in your brain, it's the information in your brain, the simulation keeping track of a limb that no longer exists. So this is the body schema, the brain's model of the body. And the brain needs that model in order to control the body, to keep track of it, monitor it, make predictions, and help control it. So that's the body schema. The attention schema is an exact parallel to the body schema. That was the idea of labeling it that, the attention schema. And so the idea is that there is a thing called attention. Um, Colloquially, people use that word in all kinds of different ways, but scientifically or in neuroscience or psychology, attention means a when your brain, especially your cortex, your cerebral cortex, focuses on one limited set of items to the exclusion of everything else, and it deeply processes those limited items so that you can respond intelligently to them. So attention is the brain marshaling its resources and focusing it on something. Um, and there's an interesting relationship between attention and consciousness, and the relationship is that almost always what you're attending to, you're conscious of, and what you're not attending to, you're not conscious of. They tend to move around with each other. They tend to move around with each other almost perfectly. It's very hard to separate them. So if you're not paying attention to that road sign as you're driving, then you're probably not conscious of it. Um, but if you are conscious of it, then you were probably paying attention to it. So attention and consciousness move together. And what the attention schema theory says basically is that when I say I have a conscious experience of something, of the red apple in front of me, I have a conscious experience of it. What's really going on is my brain is paying attention to it. It's focusing its resources on it. And my brain is building a schema, a model that depicts my state of attention. The schema, the model is telling me at a higher level, it's telling me that my brain is focusing on it, that I'm attending to it, that I'm deeply processing that apple. And because I have that model, that set of information, now I can overtly say, I am conscious of the apple. So that's the kind of the steps or the layering going on in the attention schema theory.
Right, and I think it makes sense because when we talk about attention from the time we are growing up, you don't pay attention in school or you don't pay attention to what's happening. You see the immediate results. So it's got practical applications that everyone can understand. And the more you pay attention to something, I guess uh, in popular culture as well, if somebody is when we talk about somebody who's hardworking, somebody who's attentive, somebody who's probably I would use the word conscientious is has been defined as something that most successful people have as an attribute today. And being conscientious is continuously paying attention to a particular task and making sure that task is completed. And in probably in what is popular today in the crypto world, you see all these pictures and you see the famous laser eye, the guy with these laser eyes and red eyes that says, well, these are the good investors. You follow them and the investments that they are making, and they probably have paying attention to the charts. I don't think they have deeper insight into predictions, but it's just that they're paying attention specifically to movements and are in tune with it.
Yep. So here's an example that you may have heard of that is a popular example. One of the cutest experiments out there about the importance of attention. That when you don't pay attention, it really you are not aware. It disappears out of your mind. And the experiment is it's the famous gorilla experiment. And you show people a video of a bunch of guys playing basketball, and you tell people follow the ball, pay attention to the basketball, and count how many people pass the ball back and forth. And so somebody does that and they focus their attention on that basketball. Their attention is focused on the basketball, not on the rest of the picture, right? And they watch the whole video, and then you ask the person, okay, did you see anything strange about that video? And the person says, nah, I mean, it was a basketball game, nothing strange. Then you tell them, okay, watch the video a second time, but don't pay attention to the basketball. Just try to attend more generally to the whole game. And then the person does that. They say, okay, I'll do that. They pay attention to the video. And suddenly they realize that there's a guy in a gorilla suit wandering through the basketball game, and they missed it. They missed that obvious giant weird anomaly of the guy in the gorilla suit. They did not see it. Why? Because their attention was focused on something else, on the basketball. So you are blind. It's called inattentional blindness. Your brain does not, barely processes um, things outside your attention. So attention is the key to all our intelligence. It's the key to our ability to interact with the world in a strategic way. And that's why it's so important for the brain not just to have attention, but to know about its own attention and to monitor its own attention and make predictions about its own attention. And that's what the attention schema is. It's this higher level, as you noted, metacognitive, this higher level ability to think about and model and monitor and understand our own attention. And that's the thing that I believe is what people are reporting when they say I am conscious of something.
Right. And for somebody who can probably pay a little bit more attention to this, attention to attention is what
Yes, yes.
I'm trying to say, then I understand how to, and if I'm smart enough, I can manipulate it. And then I understand how your attention works. Now, that would make me an amazing, either an amazing magicianist or an illusionist, because you spoke about the gorilla suit, but I think that's happening on every stage, on every street where you have a magician sleight of hand or whatever,
Yep, yep,
is taking your attention in one direction, and what you see is because he has mastered the art of
yep.
his attention or paying attention to his attention. Am I understanding that right?
So there is no better demonstration that people have a complex understanding of attention, that they can predict and understand human attention. There's no better demonstration of that than um, magic tricks. When the magician manipulates people's attention, gets people to attend over here so that he can do something over here that you're not noticing. A magician or any kind of performer manipulates other people's attention and does it because people know at an intuitive level, they understand how attention works. They can look at somebody else and guess, what is he paying attention to? How is that going to change? How can I manipulate that? So people have a very strong sense. This is what the attention schema is. A schema is like a somewhat simplified but still usable, helpful model. So people have an attention schema and they apply that to other people, right? So I can understand what your attention is doing, and I can understand what someone else's attention is doing, and I can understand what my own attention is doing. And now I can begin to plot out and plan how all these different attentions are interacting with each other in a social group. And that's kind of at the heart of our social ability, our social cognition rests to a great extent on our ability to understand each other's attention and manipulate each other's attention.
Right. And interestingly, when we talk about the theory of mind, for example, and study that has been conducted on small children, where people, children would there are interesting experiments to talk about how kids would react till a particular age, where they then realize that the other person is a person that has a mind of their own as well. And before that, they react to the situation right there. Now, I do know that this has been connected to probably study in autism as well, where it has resulted, or there are indications that speak about us as normal people and the amount of, our ability to lie, or our ability to deflect, and our ability to get through life using all this, as opposed to somebody who does not have what we just spoke about. But does theory of the mind also interest you, and is that linked to what you are studying in some way or the other?
So, yes, um, theory of mind is this ability to intuitively understand what's in someone else's mind. And that is connected, that's deeply connected to understanding what someone else is paying attention to. Um, in fact, in some sense, they're the same thing. So if you're focused on the donut on the table, your eyes are focused on it, your your head is aimed toward it, um, then I can guess you're paying attention to that donut, and then I can begin to start speculating. Well, what's in your mind? Why are you paying attention to that donut? Do you want to eat it? Do you want to give it away to someone else? Like what are the thought processes? So theory of mind, figuring out the thought processes in someone else's mind, kind of begins at its root. It begins with understanding what the other person is paying attention to. So attention, and what's called social attention, understanding other people's attention, is always the first step in theory of mind. And yes, in children it develops in children, so it's in a fairly simple form in infancy, and it gets more and more sophisticated as one grows up.
And your theory today is one of the top quotes, or you could say frameworks, for when we talk about AI and the ability or the possibility for us to evolve or develop consciousness in a machine. And now, that is a very controversial topic and subject, and people have set boundaries and have either on this side or on that side. And I'm still in the middle, to be honest with you. And I'm trying to get as much information as I can. But you did speak about social cognition in your paper and the benefits of that because of evolution. Now, when you talk about inducting that into a machine, at what stage does that come in? Because as humans, and if we talk about evolution, then we've lived all those times and we've won and lost and then decided, okay, this is what adds to as a benefit socially in wins and losses. But this, when it comes to a machine, for example, Michael, does that mean that we need to induct certain parameters for uh, ability or for inner drive or for somebody to have somebody who wants to be competitive? Because I think these are all other aspects that evolved along with consciousness, and as you said, these are the mind playing tricks with us, yes. But how do you tackle that question when it comes to AI or artificial intelligence? Where do you start? Is there a hierarchy of adding these layers?
So first, I will say I think consciousness in AI is going to happen. It's inevitable, um, and some limited aspects of it may even already be here. That's debatable, but it's inevitable. I would rather have it happen in a way that we actually understand at an engineering level, and in a way that we can actually manipulate and control and test to make sure that it's not going to cause some harm, or that hopefully it can give some benefit. I would rather have it go that direction than just have it emerge, um, haphazardly, without any understanding of how or what it is or what kind of impact it might have. So I am definitely very strongly on the side of understanding AI consciousness, what it is, how one engineers it, and how one controls it. Um, so I'll say that at the beginning, because there are people who argue we shouldn't do it, we shouldn't study it because it might be bad for us. And my answer is it's going to happen anyway. In fact, it's already happening. So we better understand it. Um, and so this is one of the reasons why I'm so into the AI consciousness um, topic. I think the attention schema theory is probably the only theory that can really plausibly be built, um, because other theories have what's called the explanatory gap. You always end up with some place in the theory where you build this and then you add this and you put this on, and then a magic thing is supposed to emerge, a kind of feeling is supposed to emerge. And when you ask an engineer or an AI expert to build it, and you tell them that magic essences are going to emerge out of it, they don't believe you, and it's nonsense, and that doesn't happen, and that's not helpful, right? It's sort of like if you went to the Wright brothers who were building their airplane, and you said, "Well, put this on and put that on, and then a magic essence of flight will emerge out of it." And no, that's not helpful. That doesn't solve the problem in front of you. That's not how you understand the engineering. So the attention schema theory is right now one of the few, if not the only, theory that's buildable in every single step of the way, and doesn't have that explanatory gap in there, or it doesn't allow for vague magic in there. So it's very attractive to people who study artificial intelligence because it actually makes sense from an engineering point of view. So there are a lot of people studying it right now, a lot of people trying to understand how the attention schema theory interacts with AI, what it means to even build it. And I think that you get a benefit from building in an ability for the machine to know what a conscious mind is, to know that it has one, and to know that people have conscious minds, because that is the basis for our social, cooperative, empathetic nature. Like, that's how people get along with each other. And when you don't have that, you're basically just building sociopath machines that have no capacity to cooperate or get along with conscious agents, right? So I think there's probably going to be a benefit, a huge benefit, to building, to in a controlled way, building these kinds of mechanisms into AI. But I definitely think there's a benefit to at least understanding it, so that when it does emerge in AI, we can at least know what's happening. Well, at a small level, some of our own work shows that, well, certainly attention is possible in AI. There's all kinds of methods of attention, of how machines can focus attention on this or that. Um, and we have been studying at a simpler level what it means for machines to have self models, and especially self models where they understand their own attention. So, at kind of a simple level, you see some of these components. And when you look at a larger scale, you look at something like a large language model, like ChatGPT, a study that I was involved in recently, where so these models, the chat gpt models, enormous, as the equivalent of vast numbers of neurons trained on vast amounts of information culled from the internet. um, and when you test it, chat gpt has really good theory of mind. It can hear stories about other people, and it can make deductions about the inner mind states of other people. And so there's evidence that these AI systems are actually beginning to develop the same kinds of concepts, the same kinds of models, um, possibly even self models. So it's not that they have human like consciousness, but that some of the components are there, and some of the components might be coming together. So that's why I think it's inevitable. It's inevitable this stuff is going to happen. Let's make sure we at least understand it.
So is it going to evolve and then we get to know that machines or AI is now conscious? Or is there going to be the big bang for machines and we wake up one morning and somewhere due to some circuits and inputs, there's a particular machine that is now displaying consciousness? So do you think it's going to be all of a sudden somewhere? Could be deliberate or could just have happened? Or do you think it would be over a period of time from primitive consciousness to a little bit to higher forms of consciousness?
Almost certainly gradual. And here's a second part of the problem. Mostly, when people talk about what is conscious and what isn't, mostly when you talk about, well, is my pet dog conscious? Is my friend over there conscious? Is this machine conscious? What's really happening is people are using their social machinery to attribute consciousness to something, right? And people are really good at that. I mean, we evolved to do that. We evolved to project consciousness onto things. We're really good at it. Um, and so already a high percentage of the population tends to attribute consciousness to artificial intelligence. Um, so you have a person talk to a machine, and a high percentage of people will say, "Yeah, it's conscious. It's complicated enough. It feels conscious to me." And understand, that doesn't mean it it doesn't mean the machine thinks it's conscious. It means the person thinks that the machine is conscious. And so that's something that develops gradually. That's something, as machines get more sophisticated, more and more people will start to pragmatically treat them as if they are conscious and feel as if they are conscious, until finally everyone's just going to say, well, it's all the same. They're basically conscious. So that's what I imagine will be the progression. And we're already in the middle of that progression.
And also, when we do hear about AI these days, there is a lot of talk and there is a lot of information that is coming out where research is being conducted at probably different parts of the world. And interestingly, from what you said, there is no guarantee that in one particular part of the world or country decides not to control or do what they want to do, you may lose out the race for that morality code. And if someone does it before you, then it could be too late, because whoever decides to do that first kind of gets a head start with what is to come. So, whether or whether not we leave that open, I don't know if we have too much of a choice, because if you don't do it, somebody is going to do it. And the chances that that somebody, with the way things are, may not be doing it in the interest of everybody else, if you understand what I am trying to say.
Yep, it's a scary time for that exact reason. Um, that's exactly right. But AI technology is growing like crazy. I mean, it's getting more complex, more sophisticated, and more brain-like by the year, by the month. So yes, that's exactly right. It's hard for um, anyone to do really deep AI research. It requires an enormous amount of resources, which means that there's only a limited number of agencies and places that can really build the stuff or study the stuff at a level of extreme sophistication. So there's a little bit of a limit on it right now, just because there's a resource limit. But you're right. There's no laws right now that can really restrict it, and this stuff is happening, and it's gonna happen. And so it's a little scary.
There's a thought that just came to my mind in this conversation right now as we were speaking, because we started by talking about the evolution of consciousness, or the evolution of uh, artistic representation. That's where the first paintings come out, and we talk about the cave paintings. And somehow, probably 10 years ago, 15 years ago, art was one area, one field where people strongly thought that there was no way that anybody else other than humans could come up with art. It was not really something that we would imagine, because we thought that, well, that is so intrinsic to us, no matter what happens. I don't think art is something that, and today, if you look at it and you look at the internet, or you look at ChatGPT, or you look at what's happening with AI, well, they've got some of the most amazing art, and it's impossible to tell the difference. Though it's not only tell the difference, in some cases, it's absolutely amazing, because one is picking up a particular artist's style and doing it, but that's not necessary, right? You're giving text now, and whatever the machine is able to represent that in a true art form. That, to me, is why the question I asked you a little bit earlier: is there any sign that it may already be there?
Right. So again, I would draw a distinction between consciousness or conscious experience and the things that we do, that we are conscious of. And art is a good example. So in principle, you could do art but not have a conscious experience of doing it. um, and so this is one of the things that's happening, I think, in AI is getting very good at these different kinds of skills: art, visual art, music, creating music in all kinds of different styles, text, writing text in all kinds of different styles, speaking, including a speaking voice. So AI is getting really good at that. That doesn't mean it actually has these self models that we think are what give us our consciousness, right? So I think, hasn't developed a coherent self model in the same way that a person has. It can, like, that's coming. I just don't think it's there right now. So, um, but I would say, on the general point that you're making, that there are skills that people thought nothing would ever be able to do except a person, and that turns out not to be true. There's probably no skill anywhere that is going to end up uniquely human. AI is getting really good at all of these skills, and it's only a matter of time before it outclasses people. So if you look at music, that's a tricky one. I don't think AI music is as good as some people think it is, because it tends not to build music on a long time scale with deep temporal structures within the music. It sounds really good moment by moment, but doesn't have these long kind of forms and structures that you see in human made music. Well, that's only a matter of time, and probably not that much time before AI advances to the point where it's equaling or exceeding human capacity in all of these matters. That's just something we're going to have to deal with as a society, as a species. We are creating something that is potentially trillions of times more intelligent than any biological thing has ever been. That's just what it is. It's both very exciting and very scary, and it's one of the huge transitions in the history of life on Earth. And we get to see it happen right now.
True. And speaking about music, I can see the keyboard right there behind you. So I'm sure that this is a subject or a topic that's very close to you. And just to ask you, what do you think about jazz music and AI? Because I've heard that AI will do all the kinds of music, but jazz is somehow related to some inner emotion. And that's the word we use at the beginning of this. But as a musician or as a music lover, what do you think about jazz and the ability for AI to create jazz?
Well, I don't know about I'm not familiar with any specific, studies on uh, jazz in particular with AI. I think all music is emotional, and so, for example, if you ask AI to recreate um, music in the romantic style, some kind of style of Brahms or style of Chopin that's really overtly emotional, and it can do a pretty good job. But I do think that there's limits on what it can do right now. There are severe limits on what AI can do with music right now. It's very good, but it's not human like. It's only a matter of time before AI is able to do that. And in terms of emotions, I don't think people understand emotion very well. I don't think we understand the brain mechanisms of it very well. Um, and emotions are anchored, human emotions are anchored into the body, into the physiology of the body. So the emotions we feel happen partly because we feel changes in our heart rate and our stomach, and we feel changes in our skin, the heat or clamminess of our skin. So physical changes in our body resonate and help shape our emotional circuitry in internal to the brain. This is something called embodiment. Emotions are embodied in a physical form, and therefore, I have a feeling it's going to be a while before AI really um, replicates human emotion in any meaningful sense. I think that's going to be a longer development. I don't think people are really close to that yet. But it's going to happen because technology keeps moving and moving forward.
And so, Michael, what about psychedelics as far as research is concerned, and in your current field and research that you are doing?
A lot of people are studying psychedelics. There's a growing field, and it's very interesting to people in consciousness research. I don't do that. Um, it might make an interesting tool. Thus far, I'm a little skeptical of it because I'm interested in how the brain works when it's working correctly. And I think when you pump drugs into it, a lot changes, and you don't really know what's changing or why or how it's changing. So you're messing up the state, and then you want to study the messed up state without knowing really how it got messed up. I find that a little weird. I think there's a lot of people who would strongly disagree with me, who would say that psychedelic research is very, very interesting. I'm just a little skeptical of studying the messed up brain when you can study the functioning brain.
Yeah. And from what we know or what we hear, and when I say we, I'm talking about people outside research and people who just spend time listening to what article is presented to them. Uh, as far as the brain is concerned, is it true that over evolution, we had one part of our brain that was, or that is referred to as the reptilian part of the brain, which is more related to our older instincts of fear and reaction. And then you have probably what evolved as the secondary brain, which now controls more of what you and I talking about when it comes to language and intelligence. And if this is the case, could you give us some insight into currently what your research is telling us about this evolution and these two parts of the brain and how it ties into consciousness?
It is a very common notion, the reptilian brain. Um, but I don't think that's a as usual. That's not with these public concepts that sort of get into the popular mindset. I don't think that's accurate. And I'll start with this: a reptile has not only the parts of the brain that sometimes people call reptilian, but it also has the parts of the brain that people think of as higher order, right? So some reptiles are actually quite intelligent. They have a forebrain, as it's called, the forebrain, which evolved into our cerebral cortex, which is this main thinking part of our brain. Reptiles are quite sophisticated creatures. Um, I think what people are probably referring to is there's something called a brain stem, and so in a mammal, in a person, for example, there's a brain stem, and then there's a big cerebral cortex wrapped around it. And the brain stem contains many of the structures involved in reflex and regulating the internal states of the body and basic emotions, fear and hunger and anger and so on. So the brain stem works in concert with the larger cerebral cortex. It's not that the cortex is the rational, um, intelligent part, and the brainstem is the emotional part. That's not correct at all. The cerebral cortex is like an expansion, an extra set of processing that handles all of this information. Your emotionality, your the things that people often think of as reptilian brain processes are going on inside the cerebral cortex, as well as higher thought and rationality and decision making. So it's a bit intermingled, it's a bit mixed up in that sense. Everything's very integrated.
Great. So this is a good time to do get all our facts checked with you itself. And starting that was the first one. Now the second one, and you've got to tell us. And again, I'm sure you've heard this, but a lot of people who are listening to us probably need an expert to tell us. So left brain, right brain, is that because I've been reading so much about it, and I have ended up being more confused, to be honest with you, because is there actually a left brain, right brain person, and does a left brain thinker is more analytical? No, is that the right brain thinker is more analytical, and the left brain thinker is more a doer? So is this even true?
All right. So I think the only way you can become a left brain thinker is if someone removes the right side of your brain. Then you've got a left side, and that's it, and you're a left brain thinker. Um, Other than that, you're using both sides, and you're using them in a highly integrated way. Having said that, it is true that in most people, language, or at least speech tends to be controlled by the left side. And visual spatial reasoning, like map reading, which is present in both sides, is better or more sophisticated on the right side of the brain. So there is some specialization of function. Like the two sides work together, but they do have a little bit of different skill set as they work together. But there's no such thing as a person who emphasizes one hemisphere and ignores their other hemisphere. People are always using both hemispheres all the time. Um, yeah.
Okay, so that's a fact check for everybody listening. I've got one more for you, Michael, that you're going to help us with.
All right.
How much percent of our brain are we actually using? So you know what I'm alluding to. 10%, 20%, we're not using all our brain, we're using half our brain. And there are ways to meditation through a lot of things that we unlock the secret. So, are we using all our brains? I mean, generally, most of us are not. But what would you
Yeah.
say?
There's two ways to frame that. One is what literal percentage of our physical brain are we using? And the answer is 100%. The second way to ask the question is what percentage of our potential are we using? And that's probably not very high. And just to get the point across, I think of it like learning how to run a race. So, if I try to run a race, I'm not very athletic. If I were to try to run the 50-meter dash, I'd be really poor at it. So I don't practice, I don't train. I'm way down at the very low end of the human potential. But if someone asked me, what percentage of my body am I actually physically using while I'm running? The answer is 100% of it. Like I'm using my heart, my lungs, my muscles, every part of my body is in motion as I'm running. I'm just not using it very well. And someone who's a really good runner, like an Olympic sprinter, they're also using 100% of their body. They're just using it better. So they're at a higher level of potential. And I think that's the answer. We all use 100% of our brains, unless a part of it gets taken out. We're using 100% of our brains, but some people are using them to higher potential than others.
True. And you mentioned about the brain and one the stem rather. Now we were also talking about the evolution of consciousness earlier, and we're talking about probably mammals, and then we did speak about earlier mammals. What about the spinal cord? Because I think I've been reading something recently that spoke about activity in the spinal cord that we need to pay a little bit more attention to, or a lot of activity that is happening in the spinal cord that is directly related to the brain. Because if we look at the evolution chart as well, when we talk about fish, for example, and then it gets into species with or who developed a spinal cord, is that in some way interesting at the moment to study or read more about?
So the spinal cord is a very sophisticated piece of machinery. A lot of people, when they first learn about the spinal cord in neuroscience class or physiology class, tend to think of it like a cable, like a set of wires that connects the brain to the rest of the body. And that's not correct. The spinal cord contains a lot of processing. It has a lot of neurons hooked together, doing an enormous amount of sophisticated processing. Your spinal cord is probably more intelligent than most animals on the planet. So humans have a very sophisticated spinal cord, all vertebrates, all the way back through fish. and lampreys, which are really ancient or ancient branch of fish. Uh, all vertebrates have a spinal cord that's quite sophisticated. Is it conscious? No. I mean, it's important. It processes information. It sends information up to the rest of the brain. The thing we call consciousness, that we report as consciousness, is probably constructed in the cerebral cortex. um, if you're a bird, you have a homologous structure that's similar to the cerebral cortex. Um, but the spinal cord lacks that. So spinal cords very important, very sophisticated, very complex things. I studied them at one point in my career as a motor control physiologist, but not directly involved in consciousness.
Great. No, I think that was very interesting with the spinal cord. I thought that was interesting as well, and I wasn't aware the amount of activity that is going on there. Another fact check for people listening: gut feeling. And again, we have articles that are now coming up, and again, I mean, you're probably the best one to tell us is something that people are tending to go back to. This particular phrase is what I'm talking about: gut feeling. And the amount of neurons in our gut, or is there some relation or connection that we are now finding out directly to the brain?
So gut feeling typically means an intuition. Intuition, for the most part, is probably the brain. It's not in your gut, it's in your brain, constructing information in a sophisticated way, unconsciously. And then that information becomes available to your higher cognition and you become conscious of it. That's usually what we mean by gut feeling. I have a gut feeling that there's something wrong with that person or something really good about this opportunity. That's usually what we mean by gut feeling. It's intuition or lower level models constructed in the brain, and their output is available to higher level cognition. Now, in addition to that, that's one thing. It is also true that there are a lot of neurons all over the body, including in your gut. There's what are called ganglia, or clumps of neurons that all work together to process information. And there's ganglia in your gut that are processing information about digestion, that help control your stomach and your intestines, and so on and so on. So there is processing almost like a little brain in your gut helping to control it. But I think that's probably separate from the thing people mean when they say gut feeling or gut intuition.
Right. And when you spoke about ganglia, is it also the same with probably some form of primitive life before a brain or an active brain has evolved or consciousness has evolved, but you or they can survive just with the ganglia because it helps in life anyway, or the metabolism?
Yes. Uh, so many animals don't have brains. Um, so insects have ganglia, clumps of neurons all over their body, controlling different parts of their body. They tend to have one large ganglion in the head, which is essentially a brain. um, Other invertebrates also have ganglia rather than brains. So having a brain means that one ganglion got really big and sophisticated and began to take over more functions. So the brain is something that evolved gradually over time. Um, but yeah, you don't need a brain. I mean, a jellyfish, for example, has neurons, but it doesn't have any real nerve centers. It doesn't have ganglia or brains.
True. And I do know we've taken a lot of your time, but before we let you go, just a quick question, and then I would want some advice from you. But on the topic of consciousness now, when we look at our evolution, and we've been around for as long as we've been around, a little bit of a philosophical question, but we have species, we have animals on Earth who have been around here for millions of years, probably, with no consciousness. And if we talk about survival, then do we need, how important is consciousness for survival over a long period of time? Is it without consciousness? If we have an example of a species that has survived with consciousness, obviously, and intelligence, then do we come closer to reasoning, of course? But how do you look at this as an open question? And have you ever even contemplated this?
So I think that consciousness is an adaptation, specifically to help the brain monitor and control its own state of attention. That means if you're a creature that has attention, selective attention, then it's really beneficial to have consciousness. And that would allow you to survive better and have a longer species history, right? So, um, yes, that's consciousness is an adaptive trait that evolved because it helped survival, but it helped in this narrow sense. There are other kinds of creatures that don't need it. They don't have selective attention. They don't need to control their selective attention. And so they don't need the consciousness mechanism. They have other mechanisms that help them survive. So if you look over the whole tree of life, you see all kinds um, living things like a plant, a tree. A tree does not have a nervous system. It doesn't need it. It found a different solution to the problem of how to live and survive. Um, a jellyfish, as I noted before, jellyfish don't have brains. They have loose nets of neurons. They found a different solution to the problem of survival, and they can survive quite well in their particular way, in their particular niche. But if you're going to be a kind of creature that has selective attention, that you move around in order to help guide your behavior, then you probably need something like the consciousness mechanism to help control your attention.
Before we let you go, Michael, you've been very generous with your time. What would you want to tell our viewers or everyone listening to you? I think what they would first want to know from you is, with the research that you're doing currently, what is the latest as far as consciousness in the brain is concerned, or what is something that keeps you thinking at the moment and you still need to make up your mind with, because it could probably be a new insight that has come in, new research is telling us something. uh, for our viewers, based on what you're doing and what your team is doing with its research, that's one part of the question. And the second one is, generally for students listening to this podcast and you, a general message for everyone.
I would say right now, to me, the most interesting area of research has to do with consciousness in artificial intelligence. And there's a lot of reasons for that. I think consciousness has been for a long time the domain of philosophy and then neuroscience and psychology, and it had interest value to people personally and spiritually and philosophically. But it turns out the question of consciousness has also this pragmatic side to it because it relates to technology, and it relates to technology that is changing our lives and our society. And so understanding consciousness as it relates to artificial intelligence, trying to build the stuff so we understand what it means. This is where the questions of consciousness are going to be resolved. This is where um, the the theories of consciousness are going to fight it out, and the winners will rise or fall, probably mostly in this arena of artificial intelligence, where you actually can control and study the details of a system in a way that's impossible in a biological entity. So that's what really excites me right now. That's a lot of my lab is beginning to move in that direction. And there's a lot that's not known in that domain. And there's a lot to figure out in that domain. So I guess if I had a lesson, I would say consciousness research is not just about cool philosophy. It is, partly. It is cool philosophy. It is something you can sit back and think about and say, oh, that's so interesting. Wow, I always was curious about this and that. But it's also about something of incredible immediate importance, of practical significance. the I've often said the watershed moment in our species is the moment that we understand consciousness well enough to engineer it. And we're getting really close to that moment.
And once again, from everyone here at Indian Genes, Michael, it's been a real pleasure speaking to you. It's an amazing topic, and seriously, I do hope that we can do this again because this is the first time we've spoken. We do understand a little bit more about your theory now, and I think if uh, we were ever to invite you back here again, I hope you do accept our invite. And from everybody here, once again, Michael, thank you so much, and thank you for your time.
Thank you. It was a pleasure.